Question 5. Alright, so we've been given ama statements awuthula ne-diagrams. Kakayi kwimibuzo. Okay. So kuthiwa two identical metal spheres A, B, and C carry charges of -2 times 10 to the -11 coulombs. A lo, +6 times 10 to the -11 coulombs. B lo, and -5 times 10 to the -11 C lo, respectively. Alright. So now I get my metal spheres. Yabo? Now metal spheres now A, B, and C with these charges now phezulu. Logo green are called insulated stands. Our insulated stands. What do they do? Remember, you learned yini insulator, yini conductor. Akhumbula usafunda lokho ko grade 8 and 9 we natural science. So, a conductor, it is any material that allows for electric charge to pass. But the insulator, it is any material that does not allow charge to pass. What are some examples of a conductor? What are some examples of a insulator? Okay, so ama-conductors are things like insimbi, amanzi, la izinto nje ugesi uzokwazi ukuhamba kuzona. Yabo? And then ama-insulators are things like iplangwe, uplastiki, umhlabathi, yabo izinto ey'kanjalo. That does not transmit or conduct electricity. In leyo i-insulator or plastic, which is why kunento ewuplastic that surrounds wire beyintambo zakini. Yayizonto leyo. Alright. So kuthiwa all the spheres are brought into contact with each other and then separated at the same time. Okusho ukuthi lama spheres womathathu asondelanile athintana for isikhathi esikhashana nje bese ahlukana abuyele endaweni zawo. Yabo. So this part of electrostatics, as you can see, mostly sisakhuluma ngani kumsebenzi wa grade 10. Yeah, isn't it? Why? There is no distance. Angithi? So since there's no distance, you can calculate the new charge of any of these three charges after they are separated. Sebenzisa le formula average or mean kuhlanganisa yonke into divided by ukuthi zingaki lezo zinto ezihlanganisiwe. Alright. Why are these charges negative and some of them are positive? Remember, we have electrons which are negatively charged, and then we have protons which are positively charged. Uma ama electrons emaningi kuleyo atom kunama protons, the entire atom is now negative. Uma ama protons emaningi kunama electrons, the entire atom is now positive. Uma ama electrons elingana nama protons, that atom is neutral. Ngoba akekho namandla phezu komunye. But what can we say about ama positive and negative charges? Ukuthi what we know is like charges repel. Okusho ukuthi ama charges ane sign efanayo, they repel each other. Ngithi they repel each other, they push each other away. Okusho ukuthi njengo my boots, there is a point whereby my boots abathize mawuzama ukubahlanganisa. My boots ababili. For example, let's just say la ngakwisivalo. La ngakwisivalo is the north, and then la ngezansi is the south. Nangala unorth la kwisivalo, la ngezansi usouth. Okusho ukuthi mawuzama ukuhlanganisa wena unorth no north ngeke baze bahlangane. Why? They are like charges, angithi ba positive bobabili, yabo. But mawuswitcha to a positive and a negative izohlangana, which means unlike charges attract but like charges repel. Ungakhohlwa lokho. And then la nje base besitshelile ukuthi the spheres will be brought into contact with each other and then separated at the same time. Okusho ukuthi azothintana. Uma ethintana, there is an exchange of ama electrons. Why go ama electrons? Remember when you studied the structure of the atom, ukuthi kwi atom you have in nucleus laphayana ngithi. What do you have else? You have ama protons ngaphakathi. And then on the outside, nucleus, what do you have? You have electrons. Electrons are the only ones capable of jumping to the next atom, which means I-atom ethize can lose ama-electrons and le enye ezowathola it will gain electrons. Le lose ama-electrons will be more positive. Le gain ama-electrons will be more negative. So in this case we don't know which one will gain, which one will lose. But this here, there will be a transfer of ama-electrons between these three charges. Uma bethintana. And then uma sebesuka ngesikhathi esisodwa, they will now have the same charge. Bazoba nje ne-charge efanayo bonke. Uyayizwa. So yonke into esesiyidinga ngala, yonke into ebhaliwe nje la. Injani? Idwetshiwe la. Yabo? So yabo nje la njengoba ngithi mina 2 identical metal spheres. It's actually 3 because 1, 2, 3 as you can see now, yabo. So ngibhale i-question wrong ukuthi ngithi 2 instead of 3. Ngoba as you can see now, ama charges ala aw 3, the spheres are 3. Yabo. So awukwazi kwi-statement ibethi 2. Ububona 3 wena, yabo. Alright. So manje with all this knowledge that we have right now, sesizohamba ke manje sesiyowenzani? Sesiyophendula umbuzo wokuqala u5.1.1. Asambeni siyobheka. Alright, so question 5.1.1. Sesiyazi yonke into eyenzakalayo kulama charges ukuthi bazowahlanganisa bese bayahlukanisa at the same time. And then lapho siyazi ukuthi they will now start sharing the same charge. Asikayibali ke abakasibuzi futhi into abasibuza yona bathi state the principle of conservation of charge. The principle umthetho lo of conservation. Igama lithi conservation liqhamuka kwigama lithi conserve. Abanye bathi to save. But omunye umuntu angayibuka ngelinye ihlo ukuthi to not change. Into engashintshi ezoba constant, which means the principle of conservation of charge, which means in an isolated system the total charge is constant. Kusho ukuthi 5.1.1 in an isolated or omunye angathi closed system, the net or total charge is conserved. Omunye angasho ukuthi constant. Yabo ngizama ukufaka nama terms engenzeka ukuthi shaka wasebenzise. They also mean the same thing. Iqonda ukuthini ke lento? Yini isolated system? Yini le closed system esikhuluma ngayo? So let's just think of mawupheka. Mawupheka wena, you put all your ingredients angithi ebhodweni and then you close ibhodi. At the time ulivala, there is nothing esuka ngaphandle ezongena ngaphakathi, and also there is nothing ezosuka ngaphakathi ezophuma ngaphandle. By that yonke into ekhona la ngaphakathi izohlala injalo, it will be conserved. Ngeke izishintshe, it will be constant. Okusho ukuthi the same concept with lama spheres wonke la, the total charge, the net charge ekhona kuyo yonke le system le enjani isolated noma closed evalelekile ngeke izishintshe ngoba awekho ama electrons azo escape aphume ngaphandle futhi awekho azokwazi usuka ngaphandle angene ngaphakathi. It is a system whereby the net force is 0 and there are no external forces acting on it. But there masikhuluma nge-physical sciences, uma sikhuluma ngama-forces angiklabo. In this case njengoba nakhona sikwi-physics sikhuluma ngama-forces ngala, but with respect to ama-charges, it is better called a closed system because we understand that ngenxa yokuthi kulama charges now the whole system is closed, ivalelekile. Awekho ama-charges that can escape, awekho ama-charges, awekho ama-electrons to be specific ngoba iwona phela akwazi ukugquma ngithi awekho azokwazi ukwenza njani ukugquma ayo ngena kwamanye ama-atoms noma ayo attach kwamanye ama-spheres, which is why they use ama-insulated stands. To avoid leakage yama-electrons, to avoid ama-electrons ukuthi asuke from this sphere into anything else surrounding the insulated stand. That is the main reason. So this whole system is isolated, or it is a closed system. Therefore, ngenxa ye principle of conservation of charge, the net charge in an isolated system remains constant, or remains conserved, or is conserved. Kuya ngawe ukuthi uyibhala kanjani. Ichaza kanje, I'm sure uzokwazi nawe ukuyichaza kwi-future uma usubuziwe ukuthi ithini i-principle of conservation of charge. Kungenzeka ke kube nzima ukuyikhumbula as ufuna grade 11 manje ngoba wawuyifunde ka-grade 10 ka-grade 11 most likely ngeke uzifunde uzoqhamuka kwani kwama-coulombs law. They expect ukuthi lo msebenzi kumele ngabe uyawazi, but ke when you can go back to ama-videos ase-info class aka-grade 10 under a section called grade 10 electrostatics, and then mawungene khona uzokwazi ukurecapa yonke knowledge before you start learning umsebenzi wani waka grade 11 electrostatics. Uyayizwa nto leyo? Asidluleleni kumbuzo olandelayo. Alright, now umbuzo with 3 marks. Calculate the charge on each sphere after separation. Remember, bazothathwa bonke laba bahlanganiswe. The time behlanganiswa kunalaba aba-negative kakhulu abazopha lo oppositive ama-electrons ukuze bonke babe i-charge eyodwa elinganayo with the same sign. Uyayizwa nto leyo? Siyibala kanjani? Ngithe kuwena sithola i-average. I-average yini? Uhlanganisa yonke into onayo, wonke ama-charges onayo, nawo ama-signs akhona, and then you divide by ukuthi mangaki ama-signs, which is you can see out 3. Alright, so for 5.1.2, Q new, which means the new charge is equals to charge 1 plus charge 2 plus charge 3 divided by 3. Ngenxa yokuthi awu 3. And then, so they are substituted. So Q new is equals to Q1, which is negative 2 times 10 to the minus 11, plus Q2, also about positive 6 times 10 to the minus 11, plus Q3, negative 5 times 10 to the minus 11. So divide and 3. So actually the new charge is equals to, usuthatha i-calculator yakho, kodwa qala wenza njani? Ufaka kwi-scientific notation. Uyifaka kanjani? Upressa u-shift, upressa u-mode, upressa u-7, upressa u-3. Bese uyabala. So, negative 2 times 10 to the minus 11 plus negative 6 times 10, plus positive 6, positive plus positive 6 times 10 to the negative 11 plus negative 5 times 10 to the minus 11. So divide and go 3. Sithola negative 3,33 times 10 to the minus 12. Negative 3,33 times 10 to the minus 12 coulombs. Yona ini i-charge lana on each sphere, which means u-A manje akasayena u-minus 2 times 10 to the minus 11, use-minus 3,33 times 10 to the minus 12. U-B akasayena u-positive 6 times 10 to the minus 11, use-ubani? Use-negative 3,33 times 10 to the minus 12. Kanye no-C akasayena u-minus 5 times 10 to the minus 11, naye use-minus 3,33 times 10 to the minus 12. Bobathathu they have manje ini the same charge after a separation. Why? There was a transfer of electrons as they were touching, and then they were separated at the same time. Meaning, njobethe at the same time, they mean bobathathu bazoba ne-charge efanayo. Kanti ubebethe bazohlukaniswa at different times. Laba bawu-2 abazosala bebezophinda babe nani ne transfer of electrons yabo bebodwa futhi, yabo, which is why bekubalekile ukuthi ke baseparate at the same time ukuze after separation bonke babe ne charge of negative 3,33 times 10 to the minus 12 coulombs. Asiye ngombuzo olandelayo. Alright, so nangu 5.1.3. Uthiwa la, by calculating the change in charge of sphere B, explain why sphere B becomes negatively charged after contacts. Thatha i-calculator. Into esiyaziyo thina u-B kunento asithi u-X eyenzekile kuyena ukuze abe ubani u-minus 3,33 times 10 to the minus 12 coulombs. But u-B ubani ke? Nangu u-6 times 10 to the minus 11 plus lo X lo lento eyenzekile ukuze kube minus 3,33 times 10 to the minus 12 coulombs. Yabo? So solve for X ke. So X is equals to uzoyenza njani wena? Negative 3,33 times 10 to the minus 12 minus lo ayengale phela. So it's negative 3,33 times 10 to the minus 12 coulombs minus 6 times 10 to the minus 11 coulombs. So now X is equals to 6 times 10 to the minus 11. We're going to negative 6,33 times 10 to the power of negative 11 coulombs. So yona charge engenile le ku B ukuze kwenzakalani? Ukuze u-B abe negative. Yeah, isn't it? So there was negative charges that were added on u-B ukuze u-B abe negative. How much of that charge? It was negative 6,33 times 10 to the power 11 coulombs. Okusho ukuthi during i-contact inkathi bethintana sphere B gains ama-electrons. Sifake nje u-gains ngama-capital letters. Gains ama-electrons. Uma kuthiwa gains ama-electrons, uyazi ukuthi ama-electrons are negatively charged. So if again ama-electrons ugaina ini, ugaina ama-negative charges amaningi angithi of negative 6,33 times 10 to the power negative 11, which are greater than those 6 wakhe times 10 to the minus 11. They caused ukuthi abe ne overall charge yabani ya negative 3,33 times 10 to the minus 12 coulombs after separation, after sebehlukanisiwe. Okusho but during i-contact ngenkathi besathintene usphere B gained ama-electrons kahle kahle. Uyayizwa ukuthi ngenkathi besathintana base bahlukaniswa. Njengoba sebehlukanisiwe ukhumbula usphere B has gained ama-electrons. So now sphere B has an overall charge of negative 3,33 times 10 to the negative 12 coulombs of charge. Okusho ukuthi sphere B gained ama-electrons. Ukube ube more positive, he would have lost ama-electrons. Uyayizwa lento leyo. Iyona ke into ekumele uyichaze la ukuthi kwenzeke kanjani ukuze usphere B abe negative. Umbuzo ubusho njalo, kwenzeke kanjani? Wena usuyasho ukuthi ngenkathi bethintana usphere B uwatholile nama-electrons. Sphere B gained ama-electrons. Mangakanani ama-electrons you were able to calculate ngoba bathini by calculating the change in charge of sphere B. I-change in charge uthatha i-charge anayo manje ukhipha i-charge akade enayo ukuze ubone i-charge engenile ku-sphere B. Yona into esenzile nje simple mathematics nje, solving for X as a linear equation. Uyabo? Samthola as negative 6,333 times 10 to the negative 11. Kube kuhle futhi sithole i-answer e-negative la. Ngobani? But a negatively charged ihamselana nani leyo nama-electrons, which is why sithi thina la during contact sphere B gains ama-electrons. I-answer yakho ke le for u3 marks wakho walombuzo. Asiyeni umbuzo olandelayo. Alright, so kuthiwa la 5.29 manje la. New diagram, new statement. 2-point charges of magnitudes 4 nanocoulombs and 8 nanocoulombs are placed at a distance of 250 millimeters apart. P is a point on the line joining the two charges, a distance x in millimeters from 8 nanocoulombs charge as shown below. Alright, so first things first. So now my charge is out too. we have 2-point charges separated by a distance of 250 millimeters. So kune conversion in milliseconds. Yabo? Because millimeters, medium times, I'm going to send to the -3. Because I have my meters. And then we also have another point. We saw go on a low line low or join a 4 or 8. Which is x millimeters away from 8 nanocoulombs. Yeah, and then we also need a conversion. Nanocoulombs, we can't use it with formula. We have to multiply it by times 10 to the -9. Yeah, times if it was microcoulombs, basically 1 times 10 to the -6. If it was picocoulombs, basically 1 times 10 to the -12. So in this case again, most probably we'll be dealing with Newton's law of Coulomb's law. Coulomb's law, Newton's law of universal gravitation. So, the formula looks the same. It's just that Newton's law of universal gravitation, we are talking about the gravitational force and the relationship between the products of the masses and E square of the distance between the centers. Mind you, we are talking about electrostatic force and the relationship between the force and the products of the magnitude of the charges and the relationship of the force and the distance between them. It is the same thing, but sibuka ama forces angafani manje. Ukhuluma electrostatic forces. Newton Lapha where ngama gravitational forces. So we don't know what to expect from umbuzo, but everything we need is given with statement. Yabo? Yonke into ekhona la kwi statement ikhona la kwi diagram. Ayikho into esiyidingayo enye. Sesobona ngombuzo ukuze sikwazi ukubona senza njani. Asibhekeni umbuzo wokuqala. Alright, so uthi umbuzo oqala ke 5.2.1. Specify 5.2.1. Uthi state Coulomb's law in words. Asiyisho Coulomb's law. Coulomb's law ikhuluma about the magnitude of the electrostatic force which exists between 2-point charges. Lower force, lower force. So a lower force is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Yabo? Njengoba ngisho iyafana. Iformula yakhona. Khumbula ukuthi le universal gravitation ithi F is equal to G m1 m2 over r squared. So manje le sithi F is equal to K Q1 Q2 over r squared. Yabo? So la for Coulomb we don't use le, we use le. Yabo? Alright, see stated. So 5.2.1. The magnitude of the electrostatic force exerted between 2-point charges. Between 2-point charges. Injani, it is directly proportional. Is directly proportional to the product of the magnitude of the charges. The magnitude of the electrostatic force exerted between 2-point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Yeah? So the magnitude of the electrostatic force exerted between two point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between their sensors or between them. So sichazile in coulombs law, we can now go into umbuzo. Perhaps we will be calculating, perhaps so sichaza, but we are ready for anything they might ask us. Alright, so Sibu 5.2.2. Kuthiwa calculate the magnitude of the force that the 4 nanocoulomb charge exerts on the 8 nanocoulomb charge. Ukusho ukuthi asibale electrostatic force using in Coulomb's law to calculate in the force that the 4 nanocoulomb charge exerts on the 8 nanocoulomb charge, which means the distance between them is 250 millimeters, which means kune conversion emele uyenze la koma nanocoulombs into coulombs, kunama conversions umele uyenze from millimeters to meters. So first things first, siyazi ukuthi F is equals to K Q1 Q2 all over R squared. But remember ukuthi K unikeziwe kwi data sheet as 9,00 times 10 to the power of 9. Ukanje unikeziwe i-constant le lekhona kwi-data sheet. Alright, we have unenocoulomb. Unenocoulomb ngithe kuwena, what do we do? Sithatha unenocoulomb lo sometimes ngo 1 times 10 to the power of -9. -9. So asiqhubekeni. F is equals to K now unikeziwe kwi-data sheet as 9,00 times 10 to the power of +9. And then Q1 is the charge yokuqala, which is 4 nanocoulomb or positive. So also 4 times 10 to the -9 multiplied by 8, which is 8 multiplied by 10 to the -9. And then some divide ngoba R squared, which is just in 250 millimeters. But there is a conversion factor ekhona. From millimeters to meters, we multiply by 10 to the exponent of -3. Okusho ukuthi no 250 as now. Sometimes ngo times 10 to the -3. For nje ukuthi simdivide ngo 1000. And then phela ke mase some square. Angithi kubalekile sim square because it's in definition and inversely proportional to the square of the distance between them. Isho njalo, okusho ukuthi distance mele si squaring. So now F is equals to, asithathe any calculator yethu. Sifakwe scientific notation as shift mode 7-9. And then lapho sesoba nobani? Open brackets 9,00 times 10 to the power 9. Close brackets, open brackets, 4 times 10 to the -9, close brackets, open brackets, 8 times 10 to the -9, close brackets. And then 250 times 10 to the -3 squared. Sithola la 4,61 times 10 to the -6. Ubaningi unit yakho newtons, i-force phela le. So 4,61 times 10 to the -6 newtons. Yona in there, force yakho, which means the force that is exerted by the 4 nanocoulomb charge. I-exerta kuyiphi charge? Kwi-8 nanocoulomb charge, which are separated, bahlukaniswe ubude omngangama millimeter awu 250 okanye u-0,250 meters. Leyo force exists between them. What kind of force it is? Electrostatic force. That electrostatic force has a magnitude size ongakanani of 4,61 times 10 to the power of -6 newtons. Why do we say newtons? It is because this is a force. Angithi sisebenzisa any Coulomb's law. Yabo, we calculated the force that exists between U4 no. We will call that force F1 between U4 and 8. Ukuthi ubani 4,61 times 10 to the -6 newtons. So umeda la kwi-diagram yethu. So from here on-ke manje, we might need this calculation, this answer I mean, later on asazi. So it is better to keep it properly ngala eceleni. Kuwena vele it is available ngoba kade uyibala manje paging. So usangabuka la ngaphezulu izovela. Mina ngizobe ngiyibhala la ebhodini ngoba ngiyibhalela ebhodini ngibuye ngisule angithi, which is why ngiyibhale ngala la ngeke ngize ngisule khona. So for u4 marks nje, this is what you do. Wenza njani, ubhala iformula ya Coulomb and then you add ama substitutions, but ama substitutions akho has to go within ama conversion factors. Ama conversion factors awuthi ngikunika. So uma unomillimeter, uma uno-centimeter, from millimeter to meter and centimeter to meter. So every time uniyaza ama millimeter ukuze uthola ama meter wenza njani? Uzotimes ngo-1 times 10 to the minus 3. Ku-centimeter ukuzaba ama meter uzotimes ngo-1 times 10 to the minus 2. Yabo? Kwenza kanje. And then asiyeni kwama charges. We have ama microcoulombs, ama nanocoulombs, ama picocoulombs. Kwama picocoulomb oniyeza ama micro uzothola ama coulombs. Wenza njani? Uthi 1 times 10 to the minus 6 kuzoba ama coulomb. Ngala uthi 1 times 10 to the minus 9 kuzoba ama coulomb. Kwama pico is 1 times 10 to the minus 12 coulombs. So you want ama conversion factors also wadinga for zonke izibalo ze-electrostatics. Zonke izibalo converter ngale ndlela. So if you don't have into ekanje ibhale phansi ngenxa ukuthi izokusiza phela next time mase kumele ucalculate ungenzi into engafanele. Asibonane ngombuzo olandelayo. Alright. 5.2.3 manje. Kuthiwa la a third point charge of magnitude 12 nanocoulombs, sekhonani eyosithathu, is now placed at point P, which means la ku point P sekhona u12 nanocoulombs. La ku P, ade ku P lo. Sekhona u12 nanocoulombs. Which means le point plus 3 elu12 nanocoulombs balibeka la ku3. Uma belibeka kwenzakalani? The resultant force acting on the 8 is 0. Which means i-force between u4 no-8 plus i-force between u8 no-12 isinikeza bani? U0. Yayizwa into leyo. So sebethini calculate the distance x. Remember the distance x is between u-p no-8, angithi? Alright. So kahle kahle kanje lento. Let us draw a free body diagram. Siyazi ukuthi kukhona F1 lo. Angithi? F1 or between bani u4 no bani no 8. Uyabo? So and then ukuze le force le phela ibe njani? Ibe uzothini? Ibe u0. Abakwazi ukuthi babe positive bobabili. Oyedwa uzoba negative. Uyayizwa into le. So therefore i-charge on this is negative. It is negative ukuze ibe u0. But ke which means kukhona i-force eyodwa ephuma ngala, kukhona enye i-force eyodwa ezophuma ngala. Lo ubani? U8 nanocoulombs lo oppositive. Lo part nendawo. So ukusho ukuthi F net is equals to u0 phela angithi basho njalo. So sesothini F1 plus negative F2 is equals to 0. Hayi ke u-F1 phela nangi siye sambala ukuthi uba u4.61 times 10 to the minus 6 uzolingana nobani? No k q1 q2 all over r squared. Yabo? So 4.61 times 10 to the minus 10 is equals to bani? Is equals to 9.00 times 10 to the power 9. Q1 and this is about 8 times 10 to the minus 9 ngoba unenocoulombs. Q2 sekuyile umusho kuzoba u12 times 10 to the minus 9 nayo. Kanje. And then sesamdivide ngoba ngo-r squared. Yabo? Ngo-r squared. But in this case u-x ngo-x squared. Yabo? And then ngisho ukuthi u-x squared ulingana noba x squared ulingana no 9 comma 0 times 10 to the power 9 multiplied by 8 times 10 to the minus 9 multiplied by 12 times 10 to the minus 9. Mese divide ngayo ke leya force ewuba 4,61 times 10 to the minus 6. But ke kuzomela senze njani? Sifake square root ndawo zo2 ukuze sole u-x ofanele in meters x wethu. So see see flash calculator, okay, and then the square root. In numerator we have 9,00 times 10 to the power 9 multiplied by 8 times 10 to the power of negative 9 multiplied by 12 times 10 to the power of negative 9 divided by 4,61 times 10 to the minus 6. Last ithola was 0,433 meters as our final answer. As our final answer. This is the distance between between 8 nanocoulombs nalo 12 nanocoulombs umusha, which is point P. Again ngizama ukuyichaza again the process engiyenzile ukuze kuthole lo 5 marks uphelele. So first things first, ngesikhulumeni ngama conversions. Uyazi ukuthi lo kuzomela umenzeni umconvert ake sikhombisile nanocoulombs njani ukuthi times 10 to the negative 9, which means bokubona bobabili. But ke bathe lana the net force acting on this is 0. Siyazi ukuthi lama charges lawa uma uthiwa positive angithi. So ukuze i-force yala plus i-force yala ikunikeza u0, uma le positive should le enye negative kahle kahle ukuze phuma u0 phela. Ikanjalo leyo nto. Iyalingana but in opposite direction kahle kahle. Yabo. So from here on yini esenzayo siyazi ukuthi f net is equal to 0. So f1, which is low ola, plus negative f2, which is low owalabo 8 no 12. And then sesiyazi should f1 phela uzolingana no f2 kahle kahle. But f1 ubani u4,61 times 10 to the minus 6. So ngicalculateile eqaleni. U-f2 uba u-kq1 q2 over r squared. That means according to Coulomb's law. And then we are doing the substitution with the conversion phakathi ungakhohlwa. Le substitution esoyenza ine conversion phakathi. Siqale ngakho phela uconvert. So k is a constant ukhona vele, which is 9,00 times 10 to the power of 9. Kodwa uq1 lo ubani ke? Ilo 8 weights, which is 8 nanocoulombs. Uzolingana noba no 8 times 10 to the power of negative 9. And then sibe no 12 ngala. U12 manje is 12 times 10 to the minus 9. Ngenxa ukuthi unenocoulombs. I-distance esoyifaka ke, it is the distance between yena lo 8 naye lo 12, which is x. Iformula ibino r squared. So la khona u-r sesofaka u-x kubo bani u-x squared. And then we solve for x. Okusho ukuthi if you can't solve ama algebraic equations ngeke uzukwazi ukusolve for x la, especially since you're even dealing with ama fractions. Okwenzayo you cross multiply, u divide ngalo 4,61 times 10 to the minus 6 on both sides, ufaka square root uthole i-answer yakho. Yebo. So iyona ndlela esisebenzisile ukuze sithole the distance between u8 nanocoulombs no point P, which is now 12 nanocoulombs. Iyona into esenzile ukuze sithole ini lo 5 marks uphelele njengoba unjalo. So this marks the end of question 5. Sesizoya manje on the last question kuleli paper la March of 2023. The last question, which is question 6. Iwona so bese ubheka manje. Now it is still under the topic of electrostatics, but it's more onto ama electric fields. But again, asambe siyabheka ukuthi kukanjani khona.